What's going on, and welcome back. So today's video we will go over the wire bandits, and we will cover a couple of levels in this video since some levels contain some material that need to be well comprehended. So we're gonna start with level 11 since we are at level 11 now, and we're gonna move up all the way to level 16, I guess, or 17. So before we start, don't forget to connect to the network using level 0 server. As you can see, this is the server and this is the port, and use the password you have gained from the last level we have just covered, which is level 10. Once you are on level 11, level 10 here. So once you log in as Bandit 10, you can start doing the next challenge. So starting from here. So now we are at level 10 and we're going to move up to level 11. Let's see the description of the challenge. The password for the next level is stored in the file data.text, which contains base64 encoded data. So it's very clear from the question that we need to decode the data as base64. Okay, so now we are at Bandit 10 ls. This is the data.text file, cat data. So this is the encoded text. So it's very clear, simple. We're gonna just decode that with the command base64, use the option -d for decode and data.text, and then you get the password. So as you can see, with every level, there is a new concept to learn in Linux. So now let's switch to Bandit 11 with the new password we have just acquired. Okay, so now we are Bandit 11. Let's go back and check the next challenge. So next challenge, the password for the next level is stored in the data.text, where all lowercase a, z, and uppercase letters have been rotated by 13 positions. So if we skip all of that, we know that by saying 13 positions, they are implying that the characters have been shifted or encrypted with the ROT13 algorithm. You can read on the ROT13 algorithm in Wikipedia to get more information about how ciphertexts are created from plain text with this algorithm. So basically we shift every character, as you can see here, 13 positions ahead. So A after 13 characters becomes N, and so on with the rest of the characters. Now in the challenge in here, the data.text file contains a pattern, okay, of characters that have been previously shifted. So it's already in the shifted form like that. We need to get it back and decode it. So basically we're going to use ROT13 algorithm. But of course there is no command in Linux where you can use the ROT13 directly, right? Unless you are using an external tool. So that's why we're going to use a popular command in Linux called tr. So if we type man tr, we get information about the command tr. As you can see, description: translate, squeeze, or and delete characters from the standard input, writing to standard output. So it's about characters manipulation. We can delete characters, we can substitute, we can shift. That's how the command works. Now these are the options we have. We have -c for complement, -d for deleting characters, C, replace each sequence of a repeated character that's listed in the last specified set with a single occurrence of the character. So we have a couple of options, but for this scenario, we're not going to use these options. We're going to use the pattern for ROT13 algorithm. So if you go back to Wikipedia, so see here, every character is shifted 13. So if you want to get them back, you need also to shift them 13 characters. This is an example. As you can see, the A becomes an N, B becomes an O, and so on and so forth. Okay. So Let's go now to the command line and inspect the file, cat data.txt. So this is the file. Note that numbers are not affected by the ROT13 algorithm, right? Numbers don't change. We will again change only lowercase and uppercase characters. So it's time to use the tr command. So cat data.txt pipe the output to the tr command. Now the pattern, actually, we can use two patterns. I'm gonna solve this using two options. The first one, open two single quotes and type A, Z, A, and Z. Here we type in the range. That's the first set. The second set, we also open two single quotes and we type N, Z, A, M. We have N here, Z, A, M. So what's gonna happen? Every character from the first set will be substituted with the character from the second set. So there is only 13 positions between the first and second. For example, A here will become an N. That's how we start the conversion or the shifting of the characters. A becomes an N, and the pattern will follow. After A we have B, all the way till Z. And we're gonna shift all of these characters according to this pattern. So if we type enter now, so let's take a look at the new pattern that has been generated. This is supposed to be the decrypted form. And if you take a look, it starts from here, from the 5. Everything before has been ignored. As you can see, the G became T, and T happens to be the 13th character ahead of G. R becomes E, of course. Now when R counts to E, we count till Z, and after that we start until we reach the 13th character, which is E. 8 stays the same, L became Y, 4, it's a number, stay the same. Now that's the first option. Second option is we're gonna just modify we're gonna modify actually on two patterns. So A till Z, that's right, and you're gonna remove the ZA and type MA MN ZN. That's the first set. A here becomes N, and so here we have ZA MA. Now if we type enter, it's gonna shift the pattern we have just got, right? But we don't need to change, we don't want to actually affect the right answer. So I'm just gonna show the command here, but the easiest one actually is this. So easy to follow, right? Every character from here is shifted with 13 characters, so A here becomes N, and the pattern follows. Right, I'm gonna cancel this one, but it's still an option to follow. So let's use this password and log into level 12. So now we are at level 12. Okay, let's shift now to next level. So the password for the next level is stored in the file data.txt, which is a hex dump of a file that has been repeatedly compressed. Alright, so here we have hex dump. So the file is a hex dump of a file that has been repeatedly compressed. So this means that after you decode the hex, you will get a file that was repeatedly compressed. So you have some sort of hex decode and decompressing the file. For this level, it may be useful to create a directory under temp in which you can work using make directory. For example, make directory /temp/myname, then copy the data file using cp and rename it using mv. All right, ls. Okay, let's make now directory under temp, and we name it Bandit 12 solution. Okay, now let's send it to that directory. Okay, now let's copy the file slash text ls. Now we have the file here. Okay, let's see the content of the file. And indeed, this is a hex dump. Now, if you want to get the original text or the original file, we're going to use xsd-r to reverse, actually -r, the reverse flag, to obtain the original file. This is the hex dump file. We're going to obtain the original file using the xsd-r and then data text, and send that to another file, say data v1. Okay, so we have the data v1. According to the challenge, after we retrieve the original file from the hex dump, the yielded file is a file that has been repeatedly compressed. So now we come to the level where we need to decompress the file. But before decompressing the file, we're going to need to know what kind of compression is that. So we're going to use the file command to understand the nature of the file. So it is gzip compressed data. So what we're going to do now, in order to decompress the file, we're going to need to rename the file with the mv command and put the right extension. So mv data1 v1, it's going to be data v1.tar.gz, and then we're going to decompress the file using gzip, or you can use, gzip is better actually, -d, and after -d comes the name of the file, v1. Okay, so now the resultant file, data v1.tar. Let's take a look at the file. So now it's bzip2 compressed file. So now we're going to change the file to bzip2 extension. So mv data v1, okay, to data v1, but instead of data v1 .tar, we're going to add .bz2, indicating that we are dealing with a file compressed with bzip2 compression. Okay, now we issue the command bzip2 to decompress a file, or to decompress a bzip2 file, -d, and then data v1 ls. Now we get another file, data v1.tar. Let's take a look at the nature of the file. So now the file is again gzip compressed. So we're going to return the file back to gzip. So now mv, so the file name now is data1.tar. We're going to move that to gz. All right, and then use gzip. We used gzip before. Okay, now we get another one, file data. Now it is tar archive. It's indeed a tar archive now, as you can see. Now for tar archive, we can use a tar command to decompress the file. Actually, before doing that, let me now change the file name. I'm becoming a bit confused of the one all the time, so I'm gonna move mv data v1 into data v2. Okay, file data v2. All right, now then we're gonna decompress the file with the tar command, tar zxvf, and the file name is data v2. That the completion is not working. Okay, only xf. We're gonna opt for the verbose output, so we're gonna have xf and data v2 ls. Let's take a look at this file, data 5, and this file is again a tar archive. Okay, so we're gonna need to move this file to the file with the right extension, so mv data5.bin to data v3.tar. So now tar xf data v3, and now we get another one, data 6.bin file data 6.bin. Now it is bzip2 compressed. Let's now move the data 6.bin to the file with the right extension. So data 6 data v now 4.tar.bz2. Now we use the bzip 2 -d data v4. So what do we have now? All these files are the compressed version, and now we get, let's take a look, v4. So v4 tar.bz2, after the decompression it became data v4.tar, again back to the tar extension. So we're going to again use the tar, or use the file first to understand the nature of the file. So it's again tar archive, so tar xf data v4 so it became again data 8.bin file data 8.bin. So it's now gzip again, so mv data 8. It's kind of a roller coaster. So now data 8.bin is gonna be data v5.tar.gz, and now again tar or gzip. This time we're gonna use gzip command because we have a gzip file -d, and the file is data v5. So data vf.tar.gz became data v5.tar. Let's take a look at the file. So it's text file, but it's not in the text format, right? Text extension. If we try cat now, it's gonna work. So finally, this is the password of this level. So in this level, you get to learn about compression and decompression with various extension, gzip, bzip, tar, in addition to the xsd command. So now we get to move on to the next level. So Bandits 13, and now we get the password of that. Alright, so Bandit 13. Next, go to level 14. The password for the next level is stored in etc bandit pass bandit 14 and can only be read by user bandit 14. So if we take a note of our user, we are bandit 13, which means we cannot read the password for this user. For this level, you don't get the next password, but you get a private SSH key that can be used to log into the next level. Note, localhost is the host name that refers to the machine you are working on. So here we get to learn about how to log into SSH servers using private key. So now if we tap ls, indeed we have a private key. If we cat the private key, we see this is the private key here. Now our mission is to log in to Bandit 14 using this private key. But you may ask me, how do we transfer this to the local host? You can actually transfer this to your local host, I mean your attacking machine, with the SCP, but that's the long way and not the intended way of the answering this question. We're gonna SSH to Bandit 14 from the current session we have on Bandit 13. So now SSH Bandit 14, and as said in the description here, we're going to use the local host because we are still at the same machine, but we are changing users. So -e using the private key, -i, sorry. Yes, and now we log in as Bandit 14 ls. Now let's go to the password location, etc bandit pass, or let's cat the password, cat And this is the password. Now we can take the password and log in with this password. Change to Bandit 14. Okay. Level now 14 to 15. The password for the next level can be retrieved by submitting the password of the current level to port 30,000 on localhost. So the password of the current level is this one. We took the password, right? And now we're gonna send the password to the port 30,000. So this means that the machine is actually has port 30,000 open, okay, on the local host, which means if we connect to that port, we're gonna achieve half actually what was intended in this challenge. But before connecting, we're gonna need to send data to that connection. Normally we connect to a port using nc localhost 30,000. So now if we connect, we're gonna be able to connect. See this now? nc localhost 30,000, but nothing came up. Please, or wrong, please enter the correct current password. So in order to log in, we're gonna have to send the password. So to do that, let's copy the password. In order to send the password, we're gonna use the echo command. Type in the password and then pipe that to nc, right? Now we are not only connecting on port 30,000, we're sending data at the same time. So nc localhost 30,000. And after sending the password, as you can see, we get another password. So this is supposed to be the password for the next level. So Control D, and now change to Bandit for 15. Submit in the password, and now we are at level 15. So now we're gonna move on to level 16. Okay, the password for the next level can be retrieved by submitting the password of the current level to port 30,001 on localhost, but this time using SSL encryption. So here we get to learn how to connect to a port using the SSL encryption. Of course, we're not going to use netcut. There is no way to use netcut. We're going to use OpenSSL. Helpful note: getting hard beating and read R block, use inaof and read the connected commands section in the man page. Next to R and Q, the B command also works in the version of that command. So they are referring to the OpenSSL command, which you can use actually to connect to a port and activate the SSL encryption. And regarding this option, actually, this option is used to keep the connection alive without shutting down the connection when you reach the end of the file after the connection. So what we're gonna do now, we're gonna type open or man OpenSSL. Here we get information about the tool. OpenSSL is a cryptography toolkit implementing the secure socket layer and transport layer security, network protocols, and related cryptography standards required by them. Alright, so now we're gonna go back, copy the password that we have acquired for this level, scroll all the way down and use the echo command. Start with this command, put in the password, and now to the next part of this challenge. So the next part is we connect with OpenSSL. To activate the SSL encryption, we type s_clients, indicating that we are connecting to a client with SSL activated. -connect, we specify with this option the IP and the port. Since we are connecting to the local machine, we're going to use localhost 30,001. And to avoid shutting down the connection after reaching the end of the file, we're going to use the option -in EOF. See this? After we connect it, as you can see, we get information about the encrypted connection, the certificate, and if you scroll down, you see the password. This is the password for the next level. Now you have closed Bandit 15, and we're gonna move on to Bandit 16. So in that level, you learned how to connect to a port or a client using the SSL encryption. So now go to level 16 and on to level 17. The credentials for the next level can be retrieved by submitting the password for the current level. So we're talking the same concept. We have data, we want to send it to a server, or we want to send it to a port. Previously, we learned how to send that to netcut without encryption, and we learned how to send that to OpenSSL for encryption with SSL. Now, the thing is a little bit convoluted here. So the password needs to be sent on a port, but we don't know yet which port. But it's in the range of 31,000 to 32,000. So we got 1,000 ports to try. First, find out which of these ports have a server listening on them. Then find out which of those speak SSL and which don't. There is only one server that will give the next credentials. So 1 out of 1,000 ports. The others will simply send back to you whatever you send it. And as you can see, the hint to solve this challenge is to use Nmap. Indeed, we're gonna need to use Nmap for this level. So we're gonna go back and use Nmap. Nmap is a way to scan for open ports. See what are the open ports and what are the services running on each one of these ports. Since we got one port out of 1,000 ports that will work, we're gonna need an automated tool that will do the work for us. So Nmap localhost -sv -a, without the -a, we don't need that option for now. Only -sv and -p specify a range of ports. 31,000, 32,000. Let's see here. Okay, let's take a look now at the Nmap output. The port 31,046 is still within the range we want, but it's actually it doesn't use SSL. We need a port that's actually open and at the same time using the SSL encryption. We have two, this one and this one. Both are open. So what we're gonna do, we're gonna try with port 31.5.8 and the port 31.790. Let's go ahead and do that. So now echo, and here we need the password for the previous level, or the current level actually. Alright, and then use OpenSSL s_client-connect localhost, and then we specify where's the mouse? Okay, the port. So the first port will be this one, 31.5.8. 31.5.8 dash end of file. So what do we have here? Let's see. We have the same password returned back to us. Let's take a look what's happened when you enter the wrong when you enter the wrong solution. Others will simply send back to you whatever you send it. I get it. So we're gonna change the port now. The port will be the other one, which is 31.790. Closed. So what do we got in here? Oh, correct. And we get some sort of private key here. So let's save the private key. Okay, now after we have acquired the private key, we're gonna need to log into Bandit 17 with the private key. Before doing so, let's save the private key into a text file and use that to log in. So first, let's make a directory under temp b17 And now under P17, we're going to create a new file, nano temp B17. Let's name the file SSH key permission denied. Okay, let's see if we can put that into a text file. Okay, the same. All right, let's paste the private key, save that, and now we're gonna log in with that private key, SSH bandit 17 at localhost. Before doing so, we forgot one thing actually, which is changing or adjusting the actual permissions or the correct permissions of the private key file. The SSH private key files have the permissions 600, chmod 600 temp B17 SSH key. No such file. Text. Okay. Now we log in. SSH bandit 17 at localhost -i temp B17 SSH key. Yes. And now we log in as bandit 17. Let's check back how to acquire the password. Alright, there is no information of where is the password. Let's check out cd or cat, actually cd etc bandit. It's the same place where they used to store the passwords for previous levels. That's why I'm choosing this place. ls. As you can see, we have all sort of passwords for all sort of users. Cat bandit 17, and this is the password for the bandit 17 now. All right, next one. Level 18. There are two files in the home directory: passwords old and passwords new. Okay, let's now switch to that user first. Actually, we are on that user, but I prefer to start with a clean session. So we're gonna Control D and use bandit 17. Paste. Okay, clean session now. ls. Yeah, and then we have passwords new and password old. Let's take a look now. What's the story of these two files? The password for the next level is in the passwords new. Okay, and is the only line that has been changed between passwords old and passwords new. This is suggesting that passwords new and passwords old contain the same content, except one line which does exist in the passwords new file. This is the only line that has changed, and the line that contains the password. This is a hint that, guys, you need to use a command that will show the difference between this file and this file. By showing the difference, we are displaying the content of that only line. So we're going to use a command called diff, diff. Compare files line by line. Mandatory arguments. Too long options are mandatory for short options too. Okay, we're not going to need these options actually. Just show the difference between these two files. So diff passwords old, passwords new. Show me the difference. So the difference in one line actually, and that line, this line is in passwords old and this line is in passwords new. Since our password is located in the passwords new given by the challenge, we're gonna try to log in with this password. Control D and bandit 18 now. All right, paste. Bye bye. All right, wow, bye bye. We received bye bye now. This is not the password. Let's take a look at the challenge. If you have solved this level and see bye bye when trying to log into bandit 18, this is related to the next level, bandit 19. Let's take a look now, but we don't get the password yet for the it means that the password is not this one. It means that this is the password. Let's try to log in with this password. and submit in this password. Wrong. So this means that the previous password is right, but we were given bye-bye. We need to understand why. Let's take the password one more time. Bye-bye, connection to Bandit Labs closed. Okay, so far so forth. This password is the wrong password for Bandit 18. This password, when you connect with this password, it gives you the bye-bye and it closes the connection. So what's going on here? Let's go back. If you have solved this level and see bye-bye when trying to log into Bandit 18, this is related to the next level, Bandit 19. Let's go to the next level then. So the password for the next level is stored in README in the home directory. Unfortunately, someone has modified bashrc to log you out when you log in with SSH. That was the reason. So we cannot log into to level 18 or Bandit 18 because someone has modified the bashrc to prevent us from logging in even when supplying the correct password. So to bypass this, we're gonna use something called the pseudo session allocation. So we're gonna try to log in now, sh bandit 18 at localhost, and use option -t to bypass the session allocation in bashrc file. Type in yes, Bandit 18's password. Okay, let's scroll up and retrieve the password. I hope this time works. Where is the password? Okay, yeah, this is the password. And what happened? And as you can see, we are Bandit 18 now, but there is no shell, right? That's because the limitation on the bashrc file. ls readme cat readme, and there is a password. We can obtain the password now and log into Bandit 19. And now we are Bandit 19. So we have bypassed 2 levels at once. So what happened here is we were Bandit 17, right? We knew the difference now between passwords new and passwords old. We retrieved the password for user Bandit 18, but we couldn't log in. And that's because, as per the reason, bashrc was configured to for session allocation, which means we needed to use the option -t to bypass that. And we were able to log in as Bandit 18, providing the right password. Once we logged in as Bandit 18, we found a file called readme which contained the password for level 19, and we used that to log into Bandit 19. So we're going to stop here for now. We are at level 20. In the next series of this video, we're going to continue, hopefully complete all of these. I hope you found that informative, and see you in the next video.